Okay, let's just dive right in. If you're in pre-calc, you've definitely bumped into this guy before, the unit circle. And yeah, at first glance, it looks like this giant, complicated chart of coordinates and angles you're just supposed to memorize. But what if it isn't? What if it's actually a cheat sheet that, once you really get it, makes trigonometry so much easier? Today, we're going to stop memorizing and start understanding.
So, to see why we even need this thing, we gotta see where our old tools break down. You've probably spent a ton of time with SOHCAHTOA, right? And it works great for normal right triangles. But try this one on for size. How could you possibly have a 300-degree angle inside a right triangle? I mean, all the angles are supposed to add up to 180, so something here is fundamentally broken.
And the simple answer is, you can't. Not in the simple world of triangles anyway. That's the limit of basic trig. Mathematicians hit this exact same wall and realized they needed to expand the entire playground to create a new system that could handle angles of any size, even ones that seem impossible.
So to get past that wall, we need our first big idea. We have to go beyond just the right triangle. And the genius move wasn't to throw the triangle away, but to put what we already knew inside a bigger, more consistent context. And that context is a circle.
Now, this isn't just any circle. You should think of it like a decoder ring for all of trigonometry. It has a secret code built right into its coordinates, and I promise you, once you crack it, everything just clicks. It's way, way simpler than it looks. So, here it is, our new playground, the unit circle. It's just a circle on a graph, centered right at the origin. But here's the most important part. Its radius is exactly 1. And that number, 1, it isn't random. It's the absolute key that makes all the math fall perfectly into place.
So how do we connect this circle back to our old friend, the triangle? It's easy. We just draw one in. You pick any point on the edge of the circle, drop a line straight down to the x-axis, and bam! You've got a right triangle. But here's the magic trick. What's its hypotenuse? Well, it's always 1, because it's just the radius of our unit circle.
And because that hypotenuse is always 1, just watch what happens when we use SOHCAHTOA. Cosine, which is adjacent over hypotenuse, is now just x divided by 1, which, is just x. And sine, opposite over hypotenuse, is y divided by 1, which is just y. This is it. This is the fundamental secret. Any point x comma y on the unit circle is literally just cosine of the angle, sine of the angle. That's the whole code.
Now you might be thinking, okay, sure, the coordinates are just sine and cosine, but what about all those messy numbers with square roots I'm supposed to memorize? Well, here is the best part. You don't have to. Almost every single key point on this entire circle comes from just 2 special triangles you probably already met back in geometry class.
Meets the only 2 shapes you really need to know. You've got your 45, 45, 90 triangle, which gives you those coordinates with the square root of 2. Then you've got your 30, 60, 90 triangle, which gives you the ones with the square root of 3.5. These 2 triangles, just flipped and rotated around the circle, generate every single important point. You don't memorize the circle, you just understand these 2 triangles.
Now let's look at the 4 quadrants of the circle. This is where the pattern becomes so obvious. The actual coordinate values, the 1/2, the root 3 over 2, they just repeat themselves over and over again. The only thing that changes is their sign. In quadrant 1, x and y are both positive. Hop over to quadrant 2, boom, x becomes negative while y stays positive. It's a totally predictable system, not some random list of numbers.
Okay, one last piece of the puzzle. Around this time, your math class probably switches from degrees to this new thing, radians. And yeah, it can feel a little confusing at first, but there's a really good reason for it. See, degrees are kind of arbitrary. I mean, why 360 in a circle? Radians connect the angle directly to the radius of the circle itself, which actually makes them the natural language for talking about anything circular. And listen, you can forget all those complex conversion formulas. All you need to lock into your brain is this one single fact. 180 degrees, a straight line, halfway around the circle, is equal to pi radians. That's it. That's your anchor point. Everything else is just fractions of this one idea. And just check out how simple this makes things. If 180 degrees is pi, what's 90 degrees? Well, it's half of that, right? So it's pi divided by 2. What about 45 degrees? That's half of 90, so it's pi divided by 4. See? It's just fractions. Don't let that little pi symbol scare you off. All right, let's put it all together. You've got the circle, you've got the triangle connection, and you're speaking the language of radians. You now have all the pieces to see the unit circle for what it really is, a powerful, instant answer map for trigonometry.
Okay, so let's try a typical test question. Without a calculator, what is the sine of 150 degrees? Now, before, this might have been kind of intimidating, but now we just need to look at our map.
And just watch how easy this is. We don't need a calculator, we just need the map. So first step, we find 150 degrees. Okay, that's over there on the second quadrant. Step 2, we remember our secret code. Sine is just the y coordinate. So for step 3, we just look at the point and read its y value.
And the answer is 1/2. That's it. No complicated calculations, no Soka Toa gymnastics. We just found the location on our map and read the coordinate. It's that simple.
And that is the real power of this tool. This whole system isn't about memorizing a giant chart of random values. It's about understanding a visual system, a map, that lets you find answers to pretty complex trig questions just by looking.
So, you see, the unit circle isn't just another thing to get through in math class. It's really the foundation for almost everything that comes next in pre-calc and calculus, from graphing sound waves to understanding complex numbers. It really is trigonometry's map. So the only question left is, where are you going to let it take you?